In this video, I'll show you how to fit the unconditional latent growth model in Mplus. So with latent growth models, um, we always fit the unconditional latent growth model first, and then we add predictors. It's just like any structural equation model. The unconditional latent growth model is considered the measurement model, so it's the equivalent of fitting a CFA, and then the adding predictors is a structural part, and that should be done as a second step. So mathematically, latent growth model is very similar to a confirmatory effect analysis. It's considered a measurement model because you are trying to identify the growth trajectory of the outcomes over time. Um, so for this example, I will use a paper by Umana Taylor et al. And they are interested in multiple constructs, but for this example, I will use only one ethnic identity exploration. So this is their full structure equation model. So the first part of it, just the unconditional latent growth model, is the left part of this drawing here. So they measure ethnic identity exploration with 5 waves of measurement, as it's shown here in this drawing. And they are fitting a linear model, and there are 2 latent factors: the intercept of ethnic identity exploration, which is the initial status of individuals, and then the slope of ethnic identity exploration, which is the amount of growth per unit of time. So switching to Mplus, okay, we have here, this is summary data that the authors provide. So I have the data has a vector of means, standard deviations, and correlations. So latent growth modeling is always done with a mean structure. This is how the data looks like. The summary format, we have a vector of means, then we have the vector of standard deviations and the lower correlation matrix. And I could obviously use raw data, but the authors don't provide that. Now, for the unconditional model, Mplus has a shortcut for specifying latent growth models. And I'll show you the shortcut first and then explain what it means. So this is the shortcut. So this is saying 2 latent variables. I named the intercept I, but I could have named it anything, int intercept, as long as it didn't exceed 8 characters. And then I call the slope S. And then the shortcut for latent growth models is this vertical bar here, which you can find on the keyboard above the enter key. And it's the same as measured by in a CFA, except that this can take care of 2 latent factors at once. And then we have the indicators, which is ethnic identity exploration time 1, time 2, time 3, time 4, 3 time 4, and the and time 5. So 5 measurement occasions. Now, what we specify here is just the loadings of the slope. So these are the loadings of S that you specify here. The loadings of the intercept are all 1, and Mplus sets those by default. So the loading of the slope for a linear model are 0, 1, 2, 3, and 4. This load is established 2 things. First, they establish that it's a linear model that we are hypothesizing, because the distance between the loadings across 2 measurement times is the same for any adjacent measurement times. And the other thing that this establishes is that The intercept is the status at the first measurement time. And this is established by having the at zero on the first measurement wave, right? So if we wanted the intercept to be the status at the last measurement time, we would reverse the factor loadings. We would do at -4, at -3, at -2, at -1, at 0. And if you did that, the model fit would be exactly the same, but the intercept now would be the status at the last measurement occasion. So this shorthand that Mplus has for latent growth models can be written instead the long way, just like in the CFA. And what I wrote here is all the parameters that's being specified. So if I use this long code instead of the short code, it would have worked too, right? So here is the same, I by EIE at 1. And so the loadings of the intercept, as you can see here, all 1. The loadings of the slope are for a linear model, just like above. And then we have the variances of the intercept, IS, the means of the intercept and the slope. The means are specified in black brackets, so IS. The covariance between intercept and the slope, I with S, and the residual variances, which I use the shortcut here, is IE1-IE I5 instead of writing all of them now. So this is writing in a more complete way what you can accomplish with just one line. So we'll run this model now and look at the results. So we have here, first it was fit with maximum likelihood with 181 observations. And let's give some descriptive statistics. So the first thing we do is look at model fit. So the chi-square was 6.143. So model fit is exact. The chi-square is not significant. The fit index CFI TLI showed that it is close fit. The root mean squared error shows that it is close fit, as well as SRMR. Now, for the results, there is nothing really to look at the factor loadings here, because they are all related to the growth model. In most cases, they are all fixed. But you can see that even though we use that very short code, Mplus does provide the output that the loadings of the intercept were set to 1. The loadings of the slope were set to 0, 1, 2, 3, 4. Okay. Now, in latent growth models, a lot of times we do look at the unstandardized solution first, because a lot of times you're interested in the mean and of the intercept and mean of the slope. So here, the mean of the intercept shows that the initial status, the mean initial status on ethnic identity exploration is 2.868, and that's statistically significant. Statistically significant here just means it's different from 0. And the mean of the slope is 0.016, which is not statistically significant. So this is saying that on average, there is no growth in ethnic identity exploration from time to time. Okay. Now, meaning, so the fact that there is no growth on average doesn't mean there isn't a variance in growth. So we'll look at the variance. So the variance will show whether some individuals do grow over time. Now, here we have a covariance between intercept and slope. We'll leave this alone and look later at the correlation of intercept and slope, which is shown in the standardized results. Okay, the intercepts for latent growth model are never free to be estimated. They are for identification purposes, so they're all 0. The variances here. So note that the variances are statistically significant. So there is variance in both intercept and slope, but not that much. I mean, if you take this variance here, you take the square root of it to get the standard deviation of of the slope, you see that it's small, right? So individuals vary, but not that much. And now the residual variances are here. They're typically not that interesting. We look at the I squared though, instead of looking at the residual variances. Okay, now the standardized solution. For the standardized solution here, the only part that is interesting to us is the correlation between intercept and slope, which is negative, minus 0.444. That's very common. It's saying that individuals that start lower in ethnic identity exploration grow faster, and individuals that start higher grow slower. Uh, you see that the educational data too. It's very common to have this negative relationship. Okay, now scrolling past the rest of the standardized results, we have here the R squared, and it shows that close to half of the variance, and then the last one a bit higher than half, was explained by the intercept and slope. In other words, this shows how much the linear growth trajectory that we fit through the intercept and slope account for the variability um, in this construct at NA exploration. In this case, it's mostly the intercept. So it's basically saying that you have the initial status, is what predicts what is predicting the rest of the scores across time, because there isn't that much change um, across time, right? As shown from the fact that the mean of the slope was not significant and the variance was small. So that's how you run an unconditional latent growth model.